So using Riemann sum, you need to look at a couple of things, and the first thing I want to look at here is that this is left 6. So when I'm looking at that as left 6, that means I need left endpoints. So when I make my rectangles, the left corner has to touch the curve, and 6 means the number of rectangles I'm going to use. And remember, my rectangles, if I'm using Riemann sum, are all going to be the same width here. So I'm going to come in here, and I need to make that quite a bit thinner in order to do that. I'm going from 0 to 12. So my change in x, or which is my width of each rectangle, is going to be b minus a over n. B are the two endpoints, so it's 12 minus 0 over, and I need to make 6 endpoints, so that means the width of each of them is going to be 2. So I'm going to come in here, and every 2 I'm going to make a rectangle, and my rectangle, the left corner, has to touch the curve, not the right, but the left. So it looks something like that, and again, I'm going to sum those up. So I'm summing up from 0 to 12, and I'm using my function times its width because I want the width of each one of those rectangles. So I have that I'm going to be doing right there, and that gives me the width for each one is 2, and I need to take that height, which to me looks like, let's see, 4, 5, 6. So I think it looks like about 9. That one right there looks like it's, I'm going to give it like an 8.7. That one right there looks like it's supposed to be an 8. That point right there looks like it's a little bit more than 7, so let's call it 7.2. That one right there looks like it's just under 6, but I'm going to call it like 5.9. And this one right here looks like it's trying to be 4, so I add those up. And I'm going to do that with each one of these. So if I do the right 6 here, and let's go back and let's call that one, again, right 6. So R6 means that my endpoints are going to touch to the right, and there are going to be 6 rectangles. So I need to, again, if I have a rectangle, it needs to touch to the right, something like that. I still need my width. So delta x is going to be my width, and I take the endpoints and subtract them and divide by the number of rectangles. So I have 12 minus 0 divided by 6, so each rectangle is 2, so it's just like I did before. I'm going to take a minute or a couple seconds here, and I'm going to erase this. So as I make my rectangles, again, they're going to be 2 wide, but I'm going to grab that left or that right corner like that. So I come over here, and they need to be every 2. So right there needs to be a little bit higher than that. This would be 2 right there. My width is 2, so something like this. And again, I'm going all the way up to 12. 1, 2, 3, 4, 5, 6. I feel like I didn't do a very good job last time. Anyway. So again, so these are the rectangles that I'm going to add up, and I'm going to take each one of those and I'm going to add them up, and I want the area of each of the rectangles because I'm going to sum up from 0 to 12 from my endpoints of f of x dx. I'm going to change that from dx to delta x, sorry. And that means I want the width times the height to give me the area of each of those rectangles. The width is always 2, so I'm going to put that 2 up front. And again, it's like 8.7 plus 8 plus 7.2 plus 5.9 plus 4. And then this last height right here is like a 1. And I add those up, and I just have not finished it, but I should get an answer. Midpoint, I'm going to do the same thing, so I am going to erase this again. So I'm not sure what kind of music I have going on in the background, but that is going to stop because that was terrible. But if I do the midpoint 6, again, remember M, it means that's where my endpoints touch. And 6 means the number of rectangles. So again, it's still going from 0 to 12, so I have 12 minus 0 divided by 6, or the width, which we would call delta x, is 2. And I have to draw my rectangles here. So I'm going to do this in blue just because it'll be a little bit easier to see, but I want to go to the middle between those first two, and that's my height. Okay, so then I go between 2 and 4, and so at 3, that's that height. Between, let's see, 4 to 6, that's going to be at 5, I want that height. 6 to 8 means I'm using the height at 7 because that's the middle of those. 8 to 10, which means I want the height at 9. And between 10 and 12, it means I want the height at 11. And I'm going to do the same exact thing I did before, which is find the width, which is 2 times those heights. And I'm going to add them all together. Okay, to talk about under or over estimates, for each one of those, you can tell by how the function sits above or below the curve, how the rectangles do. So number 6, you have to graph it, and I just graphed it on Desmos so that I could find my shape. It told me to go from the endpoint of -2 to the endpoint of 2. Again, if I'm looking at something like this, it's going right endpoints, and there are 4 rectangles. It's going to be left endpoints, and there are going to be 4 rectangles. Midpoint, and there are going to be 4 rectangles. So I need the width of each one of those, which we call delta x, and I take my endpoints, subtract them, and divide by the number of rectangles. So 2 minus a -2, we were asked for 4 rectangles, so that gives me the width is 1. And I'm going between -2 and 2 with the width is 1. So as I work on these, again, the width of each rectangle is 1, so therefore I can just add up the heights and multiply it by 1. Or I can find the heights for each one of those and multiply it by the width, which is 1. If it asks me for 4 rectangles, I should have 4 sets of numbers here. As I look at right, again, I'm going every 1 because it told me the width is 1. So 1 would be from like here, from here to here, from -1 to 0. Let's see, from 0 to 1, and from 1 to 2. And I'm just going to estimate what those heights are. I actually have the equation, so I could find the actual height. But for right now, what I'm going to do is I'm going to estimate. I'd say that endpoint is, the height is 0.5. That one seems to be 1. That one probably seems to be 0.5. And that one certainly seems to be 0. So if I add those up, let's see, I get 2. I'm asked to do that for left endpoints and for midpoints, so I'm going to follow the same thing I did last time. So again, each one is going to be 1 unit wide, and I'm going with left endpoint, so that first one's going to be the height of 0. Second one is going to be the height of 1/2, the height of 1, and again, calling that 1/2 the height of 1/2. So I get 1 times 0 plus 1 times 1/2 plus 1 times 1 plus 1 times 1/2, and I get again 2. So let's try one last time here with midpoint. And with midpoint, let's do blue again. With midpoint, again, because the width is 1, I need to go halfway between 2 and 1, and there. Let's see, that would be 2.5, which would be right there. So, whoopsie, so that looks like that height. Halfway between would be 1/2, so it looks like that would be the height. You do a halfway in between there, which is about right there, and that would be the height. And then halfway in between here, which would be like right there, and that would be the height. So again, the width is always the same, but the height there is maybe, if these are 2, 4, 6, 8, 10, so maybe it's 0.1, plus the width again is 1, and that height looks like it's about 0.8, 1, 0.8, and 1.1. So that's 1.6 plus 0.2, which is about 1.8. And then the last part of that says, try to improve your estimates by going with 8. So I'm just going to get this started and let you finish it up. So again, it wants you to do right 8, left 8, mid 8. And you need to actually have a graph to look at. Your width, which is your delta x, is going to be the endpoints, which are 2 minus 2, but this time you're putting 8 rectangles underneath there, which means it's 4 over 8, or the width of each rectangle is going to be 1/2. Again, I'm just going to get this started for you, and then you can finish it. So I need to have 8 of them. They are going to be 1/2. And so if I'm doing right endpoints, here is 1/2. Oops, it's just caught there at the end. Here is 1/2. Here is 1/2. Here is 1/2. Here is 1/2. Here is 1/2, like right there. This is about 1/2, and that's about 1/2. And then again, I would find those heights and I would add them up. I would do that for right, left, and midpoint. Alrighty, it's the same type of thing where you are going to be adding up. I need a marker here. So you're going to add up from time 0 to time frame 125. It's still going to be some height times the width. And so if I go, you'll notice that it's increasing in height. So as it's increasing in height, it is going to go like this, be some kind of graph like that. So if I do right endpoints, it's going to be an overestimate. And if I do left endpoints, it's going to be an underestimate. And I'm trying to see if it tells me which one to do. It doesn't, so let's do an overestimate. I don't see at least where it says. And we're going to do a right, and we're going to use all the data points we have. So those two would make a rectangle, and they will pair up like this. So I have 1, 2, 3, 4, 5, 6, 7. I'm going to have 7 rectangles, and it's always the width times the height. So the width between the first two is going to be 10, and the height, again, I'm using the upper estimate of 185. Between 10 to 15, the width or the change in time is 10, but it is 319 because I'm using the upper estimate. From 15 to 20, again, that change in time is 5, and I'm going to use the upper estimate of 447. 20 to 32 is 12, and I put a plus sign there. It's going to be 12 and 447. Yep, so I've already used 447, so I need 742. And I keep doing that until I get to the end because I want to use all my data points. Let's see, that's a 3, 14, 45, and the last one I believe is 63 times 41, 51, and then again, I would just add them up. So looking at this question, it's asking me to figure out the distance traveled. I know that this, for example, is velocity graph, which means it's the first derivative. And if we find the area under that, what we end up with is we will end up with the position after a period of time. If I do my rights, let's see, and if I do right and I do every one, so I'm just going to call it right 6, my left 6, and I do my midpoint 6. If I do right 6, so my right 6 is going to be like this, so it's going to look something like that. Right 6 like that, something like that, something like that, something like that, and something like that. I can see right 6 is going to be an underestimate. And if I come in here and I look at left 6, and let's just do that in a different color. So left 6 would be like right here. And again, we're just assuming we're going to go count every second. We're not going to go smaller than that. And you can see that that is quite the overestimate. And so then let's take a look at the midpoints. And my midpoint will do that. Let's see, I did red, I did blue. Let's do black. So my midpoint is going to look something like this. My midpoint is going to look something like this. I'm going to go to the middle. It looks something like this. And so it looks like the midpoint is probably going to be the best estimate. And so I've just decided I'm going to use midpoint. And I know the width is always going to be 1. And so I'm going to use the midpoint 6. The width is 1. And this height is going to be, I don't know, like 52. Plus the width is 1, and the height looks like it's 40. plus the width is 1, and the height of that looks like maybe it's 28, plus the width is 1, and the height of that maybe looks like it's 18, plus the width is 1, and the height of that maybe looks like it's 10, and then the width is 1, and the height of that one right there, oh, I'm going to give it a 3. I don't know. And then I would add those up.